Officially, hello everybody. Welcome to the Educators Assemble live stream. We're going for this being the sequel, Return of the EduTubers, after what happened last week, but we're not going to talk about that, even though I just did. So the idea of this is we are all sort of educational people who operate online and on social media, and we thought it'd be super fun to all get together, have a bit of a chat. We've sort of entitled it a fact session is the seems the most appropriate title. So we're going to take it in turns in 5 different rounds to talk about various things about ourselves, about our subjects. Obviously, please do interact in the live chat. We will also have time to answer your questions and different things as well. And I'd say that's about it, rather than me babbling on any longer. I feel like, well, maybe I should introduce myself first. So we have an order, we have a running order next to me on my board, which you probably can't see because I'm currently quite small. But this is going to be the order we're going to go in each round. And then the rounds are written over here on this side of my board. So round 1 is introductions. So I guess possibly, as this is hosted on my channel, I'm very fortunate. The majority of you may already know about me and what I do, but short and sweet, I am a mathematician. I teach at the, yes, I should change the view off gallery, right? Because now we're going, okay. So I am a mathematician. I teach at the University of Oxford. I do lots of online stuff. It's all Tom Rocks Maths website, tomrocksmaths.com. I even got it tattooed on my arm. So I'll zoom into the camera to show off. What I try to do is get across my passion for maths and try and make maths as fun as possible, in short. Couple of other things that I do that I want to point out. I've been on Numberphile a fair bit, which is by far the best online maths channel. Even though in theory, I suppose they're my competitor, they are so great. So if you're a Numberphile fan, you may recognize me from some of their videos. I've also collaborated with other maths channels. So 3 Blue 1 Brown, Grant is amazing. I managed to convince him to do math speed dating with me, which is very entertaining. So I'm going to recommend everyone should check that out as well. And the other thing I do, which I won't be doing today, is one of my ways to try and make maths more entertaining and fun is I often perform as the naked mathematician. So this involves me basically doing maths lectures in my underwear. So if you're keen, maybe you're not, I imagine most of you probably won't be, but if you are, those videos do also exist. They're called Equation Stripped on my YouTube channel. Right, so passing over next to Gabby. Gabby, would you like to tell us all about yourself?
Sure. Hi, everyone. My name is Gabby. If you're coming from my Instagram page, you would know me as Gab Loves T Cells. So that will be in my little name card in the bottom left-hand corner. I am a rising second-year immunology PhD student at the University of Michigan. So I'm from the United States. And my thesis project is studying how obesity contributes to increased morbidity and mortality during bacterial infections. So very, very interesting to me, at least. And so I have 3 main platforms that I do science communication on. I have my Instagram, which is Gab Loves T Cells. I have my YouTube channel, which is just my name, Gabby Heisinga. And then I also have a podcast called Tales of a Grad Student, which is available on Spotify, Apple Podcasts, pretty much everywhere that you can find your podcasts. And really what I try to do as a science communicator is normalize women in STEM and women in medicine. There's a lot of misconceptions out there that we might be boring or stuck up, but really, I'm just your average girl. I love fashion. I love hanging out with my dog. I like going for runs. I love being in the lab. And so I'm just trying to normalize what it's like to be a woman in this environment and get more women and girls excited about STEM. So I'm going to pass it over to Matt now.
Hello, guys. My name is Matthew Espinosa. I'm so excited to be part of this amazing group of educators. I'm obsessed with anything from productivity to memory and now recently language learning. I'm actually a memory champion and a chess champion here in Canada. And I love productivity, anything involving productivity. And I've actually created Brain Companion, which is this kind of educational brand as a literal companion for your brain. On Instagram, I focus more on myth versus truth. For example, people believe that you use 10% of your brain when in reality, you use pretty much all of it all the time when you're sleeping. So I try to give accurate information over on Instagram. On YouTube, I focus more on the study tips. I'm doing a challenge right now where I'm learning French in 1 month, and I'm going to be showcasing my progress at the end of the month. And I have a new video coming out tomorrow, ideally, talking about how to be a genius like Albert Einstein, where I analyze his daily routine, his mindset, different actionable techniques that you can use from his day-to-day life. If that sort of videos kind of interests you, I recommend typing in Brain Companion on YouTube, of course, after this live stream. And I think the link is also in the description, if not mistaken. And be sure to check out everyone else as well. They're doing some really cool stuff. I'll pass it over now to Katarina.
Thanks, Matthew, and thanks to you that I can even be here. So I'm Katarina Fink. I'm an Italian polyglot, and I just love languages. I actually am studying my 6th language right now, which is Chinese. So I do speak 6 languages, and that's what I kind of showcase on my Instagram and on my YouTube. I'm actually trying to get people to be motivated to learn languages. I give them tips, tricks, how to learn languages, how to effectively learn languages. And at the same time, I do a lot of collabs. Right now, I'm having a collab with Matt, to be frank. And I just showcase that on my Instagram, where that's my name. I am Katarina Fink, and just on YouTube, Katarina Fink. Yeah, that's about me.
Hi guys, I'm Bexy. I have a physics degree from Cardiff University here in the UK. I graduated about 4 years ago, and since then I've been working as a systems engineering consultant for companies like Airbus, EDF Energy, and Culham Centre for Fusion Energy. And I've recently started a science YouTube channel called Science with Bexy. So basically, ever since I have been working, I've been volunteering for STEM activities, so doing presentations at schools and attending careers fairs at schools, universities, and even airports. So I've just been trying to get involved as much as I can. And then like a couple of months ago, I was thinking, how can I extend my reach? How can I reach more students and more young adults? So that's why I started my YouTube channel. I feel like growing up, I never really had that relatable science role model. They were either amazingly, intimidatingly intelligent, and most of them were male. So I guess that's what I'd really like to be. I feel like physics especially has a really bad reputation for being boring, nerdy, and difficult. It's all kind of summed up in Sheldon Cooper, I think, and I would love to try and break that stereotype. So I guess I started the channel to try and break down barriers that tell students that only a certain type of person can be good at STEM subjects, and try and encourage people to get involved, get excited by and engaged in science. I make little physics videos that are about 3 to 7 minutes long, and I try and make them funny and silly, but also get the educational content across. And I think in the future, if this goes well, I would love to branch out into the other STEM subjects. Just keep it on going. So that's me. On to Danny.
Thank you. So I'm Danny Hatcher. You can find me on Instagram, Twitter, Facebook, LinkedIn, and YouTube, all Danny Hatcher, exactly the same profile picture. My background, I've done my undergraduate degree in sports coaching, mainly focused on pedagogics, not just football. My master's degree is currently in strength and conditioning, which is similar to a PT, but for high performance athletes. And I'm actually not doing anything with regards to my higher education. So I help people, students, and some businesses work smarter rather than harder. So just because you're putting loads of hours into something doesn't necessarily mean you're actually getting towards your goal. I know as a student, I was putting hours of work into something, and sometimes I'd look at it and go, actually, I haven't got any closer to the goal I was set out to do. So actually try and help people to be a little bit more intentional with their work, currently through using an app called Notion. Those of you that don't know what Notion is, essentially it is a task management, project management, all-in-one workspace that you can create what you want. So it's classed as a no-code app that you can take notes on and do whatever you want with. And I try and help people use the app to be as productive and efficient with their time as they can. Very similar to what Matt talks about. So that's a bit about me, and I can't remember who's after me. So Tom, help.
I believe that's me. Hi, everybody. My name is Chelsea Barretto. I am currently an environmental science and biology teacher in New Jersey in the USA. Before that, I got my master's in ecology, and I focused on mangrove ecosystems in Florida and in the Bahamas, looking at how climate change impacts those ecosystems. So I started my my Instagram page, which is Chelsea B Biology, not too long ago, because I'm really interested in science communication and bridging the gap between the public and scientists, and to have a place where even younger kids can go and look at facts that are broken down or science lessons, and hopefully in the future some fun science videos, which I'm starting to work on. So yeah, so that's kind of why I started my Instagram. I just love science communication and want to share some bio knowledge with everyone I can. So that's me. On to you, Julia.
Hello, I am the last speaker in the round. So when you see my face, you know we're going back to Tom after that. So I am Julia Evie. I'm a final year PhD student at UCL in London, and I study neuroscience. So I've studied neuroscience now for 8 years. I'm in my 8th year at my university. And really, it all started out with I just have a passion for the brain and trying to understand how our brains work. So I decided to start a science communication endeavour about 2 years ago now, so halfway through my PhD. And the real motivator for this was because a lot of my friends aren't scientists and they were really interested in my work. And I just think, why should scientists' work be kept among scientists? I think we have a duty to the public to share our work with everyone. And especially my research, which is in Alzheimer's disease. So many people are affected by Alzheimer's disease and dementia. And I think that those people deserve to know the most up-to-date information from the field. So I started my Instagram 2 years ago, and then I branched out into YouTube about 6 months ago. I'm like a very chatty person, and I just thought it would be fun to get a bit more interactive with my content. So I started to make videos all about the brain. So it's a little series called Your Brain Explained. So all about the different things that make us human. And then also videos about science in the news coming out. And most recently, I've started documenting my PhD thesis writing journey. It's painful, and I thought I want to share that pain with everyone. So that is what you can find on my YouTube channel. It's just Julia Evie Science, and that's the same for all my social medias. So back to you, Tom.
Awesome, thank you, Julia. I feel like we're doing like a news program where you were like, back to you, Tom, over in the studio. Super fun. Right, so thank you very much, everybody, for all the introductions. Hopefully everyone tuning in, you now have a bit more of a feel for everybody that's involved in the live stream. So we've got, again, I've written all of the subjects here to remind us all, but we've got Gabby with immunology, Matt, study tips, Katerina, languages, Bexy, physics, Danny, Notion, his online platform, Chelsea, biology, and Julia, neuroscience. So if you have any questions specific to any of those topics, then pop them in the live chat, and we will, as I said, we're going to try our best to answer some questions in between the rounds. But seeing as I can't see any current questions, and that was just the intros round, let's kick off with some actual content. So round 2, again, listed on this side of my board. It's really helpful having a giant blackboard. Number 2, we're going to talk about fun facts about our particular field, our particular subject. And the one I want to tell you all about relates again to another one of my tattoos. So I have quite a few maths-based tattoos. Not every round will be appropriate to a tattoo, though quite a few of them will. So I want to tell you all about a particular sum or a particular series in maths. So if we start with the following, if you take, let's say, the number 1, and then you add the next number in the series is going to be 1 divided by 2. And then you take the next one, which would be 1 divided by 3. And 1 divided by 4. And we go forever. So we want to calculate the total of this sum, and it's going to go forever. And the pattern, if we were to write it mathematically, we're doing the sum of 1 over n, where n starts from 1 and goes to infinity. So don't worry if this notation makes no sense to you. The key thing is it's 1 plus 1 divided by 2 plus 1 divided by 3 plus 1 divided by 4 plus 1 divided by 5, and you keep going forever and ever and ever. Now this is equal to infinity, or tends to infinity, I should say, if I'm doing this properly. Now my super fun, I'm not going to show you that. That is a fun fact in itself. But my favorite fact is actually what happens when you very, very slightly modify this particular expression. So instead of having 1 over n, if you change this to n squared, then you do 1 plus 1 over 2 squared, so that becomes 1/4. 1 over 3 squared, so 1 over 9. Then it'd be 1 over 16. And then it would be 1 over 25, and you would carry on. So you're just doing 1 divided by the square numbers, and you add all of these together. So all we've changed is made the numbers squares on the bottom. So this one is not equal to infinity. This one is equal to pi squared divided by 6. Now, hopefully, if you've never seen this, your mind's just been blown, or you have no idea what I'm talking about. Either way, this is my favorite maths fact. If you do 1 plus 1 divided by all of the square numbers, your total is pi squared divided by 6. And there's absolutely no reason for that to be the answer. But yet I can prove it 10 different ways, but I still don't believe it's true. And that is why it is my favorite maths fact. I did mention that I would say something about the tattoo relation. So on my arm here, so this line at the top is 0. The first line is 1. The next one would be plus 1/4, plus 1/9, and carry on forever. And the dotted line is pi squared over 6. So it's like a visual representation of my favorite maths fact. Right, Gabby, over to you.
Well, geez, it's hard to follow that one, Tom. And so my favorite immunology fact is actually not related to what I study. It is related to immunotherapy. And so basically what immunotherapy is taking your own cells and taking them outside of your body and modulating them in some way, and then putting them back into your body to treat some sort of disease or tumor that you have. So this is a really hot spot right now for cancer therapy. It's really, really hard to treat cancer because cancer is a disease of your own body. It's your own cells that are mutated to grow and divide without control. It is your body on steroids. It has no control. And so one of the cool things that I really like in immunotherapy are CAR T cells. And so basically T cells are immune cells that are constantly circulating through your body. And so what you can do is take a blood sample and purify the T cells and then engineer them with a receptor that is specific for your specific tumor. So maybe it's a liver tumor or a blood cancer, maybe like a skin cancer. And then those T cells can get put back into you. And because they're your own cells, your body isn't going to recognize them as foreign. And so you'll be able to tolerate this therapy very well, and your own cells can go and attack your tumor. And I think that is so, so cool. If I wasn't doing what I am now, I definitely would want to be in cancer immunotherapy because it is such a cool research spot and it has the possibility to help so many people. So outside of doing host bacterial infections, I also learn a lot about cancer therapy. So that is my favorite immunology fact. And now I'm going to pass it on to Matt.
Okay, awesome. That's a really cool fact, Gabby. Thank you so much for sharing. Since I focus mostly on study tips, I did want to share an interesting study that they had, I think, 4 to 5 years ago, with the relation of chewing gum. So if you actually chew gum when you're studying, let's say you're studying physics, for example, that's perfect for Science of Becky. Let's say you're studying physics and you're chewing gum. If you chew that same gum while you take your physics test, you actually have a higher correlation of actually doing well in the test because there's a higher familiarity between that kind of flavor, especially even like with songs too. If you listen to this, obviously you can't listen to a song in a test, but if you just do the same action of chewing gum when you're studying something, and then when you're taking a test, chewing that exact same flavor, I think the important part is the flavor, then you're actually able to remember the things that when you first chewed the gum, and you often just correlated with higher results. And then something else I wanted to share study tip wise is that most people believe that the best answer for a test for multiple choice is C. People always joke around that, oh, C is the best answer if you have to guess C. They actually did another study basing the 4 multiple choice answers. So if you have a multiple choice question from A to D, the best answer is actually B at 28%. So normally it's like 25, 25, 25, 25, but B actually has the highest chance. So if you have to guess B, which is kind of interesting. And then to go along with that, if the answers are from A to E, so the options are A to E, the best option in that case is actually to choose E. So if it's from like A to D, choose B, but if it's A to E, then choose E. But anyway, something interesting to do when you're studying to hopefully kind of increase your marks, a couple little hacks. And on to Katarina.
Thanks, Matt. So B and E is the answer then. All right, so my favorite fact in language learning is actually, and that's something I cannot even believe myself, is that languages can change the way your personality is, and like depending on what language you speak right now. And I think I came up with my own reason for this. So if I speak German, my native language, I'm confident, right? I'm confident speaking it. But then when I switch to other languages, I actually sometimes back up saying stuff I want to say because maybe I'm not that confident talking the second language. But I've read another article that says that every language is linked to a culture, right? And there was actually a study where people bilingual spoke Spanish and English. When they wrote 50 minutes about themselves, when they wrote in Spanish, they wrote about their family, they wrote about love, they wrote about their relationships. When they, on the other hand, wrote the same text about themselves in English, they wrote more about school, they wrote about business. So that also kind of shows that every language is linked to culture. And that's so interesting in my opinion. So it's actually great. And I think that can actually lead to your personality changing depending on what language you speak. That was my little fun fact in languages, and I'm excited to hear yours, Bexy.
Yeah, that was so good, Katarina. Nice one. My fun fact is about the hottest place in our solar system. So our solar system consists of our star, which is the sun, and the 8 planets that surround it. And you'd assume that the hottest place in the solar system is the sun, because it burns at about 15 million degrees C, which is pretty high. But actually, the hottest place in the solar system is right here on Earth. Scientists have built machines that have trumped the sun's core temperature. Like CERN have produced a machine that can burn at about 4 to 5 trillion degrees C, which is huge. But I want to talk about one that's here in the UK, and I want to talk about fusion. So whilst the jet reactor at the Culham Centre of Fusion for Energy is up and running, this is the hottest place in the solar system. So basically, the sun produces its energy through nuclear fusion, and in order for the hydrogen atoms to fuse into helium, they have to be traveling really, really quick. And the sun facilitates this by having really hot temperatures, which gives them energy and therefore speed, and it has an immense pressure. Whereas when we're trying to replicate this on Earth, we don't have the same amount of pressure that the sun does. So we have to up the temperature in order to get the hydrogen atoms to move as quick as we can to get them to fuse. Therefore, we have to run this reactor at about 100 million degrees C. So when we're running these pulses of plasma, it's burning at 100 million degrees C. And I think that is crazy. And it's just so important to try and research fusion and stuff at the moment, because it's a renewable energy, it's much safer and less radioactive than nuclear fission, which is what we currently use. And I mean, the fuel is hydrogen, which we have an abundance of. So yeah, I think the main struggle at the moment is trying to get the temperature lower, the hydrogen atoms to fuse. There's a lot of tough work in there to get it going. But yeah, I think that's my cool fact, the fact that we can house the hottest temperature in the solar system when some of these machines are running. I think it's just incredible. And on to you, Danny.
Thank you. Like, I'm following people and I'm learning like every single thing someone has said. I'm like, I didn't know that. So I'm learning with everyone watching. So obviously Notion is an app. I could give facts about the app, but that's just features of the app. So I'm actually going to take a little bit of a different route and go theories. So social science theories. Some of you may be familiar with Parkinson's law, and essentially it suggests that the longer you have to do something, the longer it will take you to do it. A good example that I use when explaining this to a lot of students is if you have an essay deadline, say in September, and it's January, it will take you that whole time to do it. You either do little bits all the way up until you get there, or you do what most people do and do absolutely nothing until like 2 weeks and cram it all in. And that is essentially Parkinson's law. What I try and do to change that using Notion is actually assign a due date. So you normally have a due date, so when the essay is due in. If you set yourself a due date, so when you're going to action something, say you're going to do the introduction in January, you're going to do the first part in February. You can essentially change that. So the Parkinson's law will then change to the due date as long as you're consistent with yourself. So you can actually get something done in a shorter amount of time than you may think. So when you are doing essays or assignments or revising for something, instead of it taking 6, 7, 9 months in case of doing PhD like Julia, if you're spreading it all out and you suddenly go, oh, let's do my PhD in like the last month. Bad idea. Bad idea. So spreading it out and putting due dates in so that you can get the things done in that time gives you that spare time to either edit, critique, synthesize information, or just give you free time to relax because you've already done it. I use Notion to do that by putting due dates in, but you can use any sort of calendar app or just a piece of paper. So that's my fun theory fact. Over to Chelsea.
Nice, that makes a lot of sense. Okay, so biology is a really broad topic. So I decided to focus again on my favorite tree, mangroves, my favorite ecosystem. So if you haven't seen mangroves, they're the super cool trees that you find in the tropics that have these big aerial prop roots. They're called prop roots. So if you've ever gone like kayaking in Florida or in the Bahamas or something, you might have seen these really cool trees. Again, my favorite tree. So the fun fact about them is, along with their cool aerial prop roots, they also have something called pneumatophores, which are breathing roots. So basically, they the big aerial roots go down into the mud, and then the ends of them stick up. And at the end of that, they have an opening that allows them to basically breathe and take in air. So if you haven't seen it, you should Google a picture of mangroves and their cool pneumatophores or breathing roots. Yeah, I just think they're awesome. And that's my fun fact. Over to you, Julia.
Great, that was so interesting. So my fact is going to be about a specific region in the brain. It's probably my favorite brain region, and it's called the hippocampus. So the hippocampus is the memory region. What it actually is, it doesn't store your memories. It's the region that it acts like a personal trainer. So when you get new information, a new experience happens in your short-term memory, the hippocampus then decides whether that's really important and your brain wants to keep that, or if it's not important. If it is important, the hippocampus will activate and it will start to strengthen all of the brain cells involved in that experience. Now, if you remove the hippocampus from someone's brain, which I would not recommend, but was done back, I think in the 1960s or 50s, a long time ago, there was a patient who had his hippocampus removed because after being in a road accident, he had really, really bad epilepsy around that region of his brain. So the doctors took out the hippocampus and they found that his seizures were really lessened, even like cured. So it did its job in terms of the epilepsy, but what this person was left with is a very, very short memory. So they could remember things for only 30 seconds. And that is because that trainer wasn't in their brain to be able to switch on the neurons to say, we need to keep this information. And this person could only remember information from a year before their accident. So what this tells us is the hippocampus keeps training these memory traces in the brain for almost a year to keep them in that permanent storage. So this man could remember things from a year before his accident, and then after that he lived till he was in his 80s, and he only had a 30-second memory. And this is also the brain region that is really affected in Alzheimer's disease. It is one of the first regions to lose brain cells, and that is why the main symptom of Alzheimer's, the first thing you see, is memory loss. So yes, that's my fact. So now back to Tom for the next round.
Thank you, Julia. I feel like super interesting, but that poor chap who's had his hip, like, oh dear. But that's awesome. Again, like Danny said, I literally learned something new from every single person. So this is super fun for all of us, as well as hopefully everybody else watching. So thank you again, everybody, for sharing your fun facts. Right, we've got at least one question. So you know what? Seeing as we want to make this as interactive as possible, I'm going to throw our current one live chat question over to you, Bexy. So Beth has asked, question for Bexy: how do they get the temperature that hot without melting what it's contained in?
That is a great question, Beth. Yeah, so the first thing we do is we contain it in a magnetic field. So we like control the shape of the plasma using like loads of magnets, and keep it in the path, and that contains it in kind of the center of the reactor. So like this reactor is a donut shape, it's a tokamak. So it keeps it in the kind of donut shape. And so, yeah, hopefully the hottest bits of the plasma are just right in the middle, and we build the first wall, so the container, as far away as we can, I guess. And for the first wall, we just use stuff like tungsten and beryllium, just like really strong metals, so nothing too special. But it's that type of thing that's stopping us from running really long pulses. We're only running 20 seconds at the moment, because our materials can't handle the like neutral load, the heat, everything that comes with it all. So yeah, that's it.
Thank you, Bexy. I actually interviewed a couple of fluid dynamicists. So I didn't mention at the beginning for everybody, my research is in fluid dynamics in maths. And I interviewed recently a couple of fluid dynamicists who were working on the fusion problem that you were just describing, because combustion itself is basically a fluids problem. And so they're actually heavily involved in trying to create this fusion reactor, like you mentioned, about trying to create this new source of renewable energy. So,
yeah.
Very cool stuff.
We're currently just using up more energy trying to get the thing going than we're getting out of it. So I think that's the next thing we need to figure out as well.
Yeah. Right. Okay, then. I'm not seeing any more questions yet. So, of course, everyone in the live chat, do key, if a question pops into mind when somebody's talking, do just write it in the chat, and then we'll come to it at the end of the round, I think is going to be the plan. As you can tell, I'm making this up so I go along, freestyling. So I think we'll go on to round number 3 then, which is the Mythbuster. This is the one I've been looking forward to the most. So I think the way I interpreted this is we're all going to present something that is a myth in our subject field, and hopefully try and correct it, or at least talk about why it's a myth, or so this should be quite interesting for sure. And I'm especially looking forward to Matt. So I'm looking forward to them all, but especially Matt, as he was saying, a lot of what he does is actually like busting study myths. So I hope he's got a good one for us. So the one I'm going to talk about in something that obviously from maths, and it's something that's talked about as basically something you can't do, in short. And generally that's a good rule, but I'm going to give you an example of why maybe it might not be as true to say you can't do it. And what I mean by this is 0 divided by 0. So I guess the myth is that 0 divided by 0 is nonsense, and we cannot possibly make sense of what 0 divided by 0 is. That is what I'm calling the myth. And what I'm going to say is, in fact, 0 divided by 0 can be absolutely anything that you want it to be. The trick is to do with how you take your limit. So that depends on the function that actually is going to equal 0 divided by 0. So as an example, if I want to consider, the classic example would be sine x divided by x. So this is my function, and I want to take the limit as x goes to 0. So when if I were to just substitute in the values, sine of 0 is 0, x at 0 is 0, so this is 0 divided by 0. Now, if you do this properly, as in you do the rigorous maths behind it and take the limit in the correct mathematical manner, this will be equal to 1, in fact. But this does not mean that 0 divided by 0 is 1, because I'll give you another example. If I consider sine of x divided by, I think I want to do x squared and take the limit as x goes to 0. Again, sine of 0 is 0, x squared is 0, so it's 0 divided by 0. But this one is equal to, let me make sure I write the wrong down. Yeah, this one goes to infinity. So in the top case, case 1, 0 divided by 0 is 1. Case 2, 0 divided by 0 is infinity. And then I'm going to give you case 3, which will be the limit as x goes to 0 of sine x divided by the square root of x. Again, sine of 0 is 0. The square root of x, square root of 0 is still 0. And this one is equal to 0. So 0 divided by 0 can be literally anything you want it to be, as demonstrated by these three examples. Very similar functions. They are all evaluating 0 divided by 0, but you're taking the limit in a different way each time. So you get 1, infinity, or 0. Right, over to you, Gabby.
Well, that definitely blew my mind as someone that has historically struggled in math. That was a lot for me to take in, but that's really cool. Okay, so my immunology myth is that the flu vaccine will give you the flu. I have heard many people say this. My own parents have said it. I have said it. I, for a long time, said that I would not get the flu vaccine because it gave me the flu. And I am here to tell you today that that is a myth. So the flu vaccine that we get every single year is usually made up of 3 to 4 different flu strains. However, there can be even more than 4 flu strains circulating at any given time. And it is up to microbiology experts, epidemiology experts, immunology experts to try and determine which strains are going to be most popular for that year. Sometimes they get it right and everyone who gets the vaccine gets protected, and sometimes they get it wrong and there's a different strain that's going to be circulating. Also, it takes the flu vaccine about 2 weeks to fully get your immune system trained. So what a vaccine does is it takes a small portion of whatever pathogen, so it could be a virus or a bacteria, and it goes into your body, and either it's mutated in some way that it can't replicate, or it's possibly a dead bacteria or a dead virus. And so your immune system will see it and train itself to recognize the invader. But it does take a good amount of time to get that memory response. And so if you're infected with the flu, between about like 2 weeks between the time that you get the vaccine and the time that you're fully trained, you still are going to get a reaction to the flu and get sick. So you're not getting the flu from the vaccine, you're getting it just because you got the vaccine at the wrong time. So I highly encourage everyone that is able to get the flu vaccine to get it as soon as it's offered. So I usually get mine in September or October. Because the earlier that you get it before the peak flu season starts, it gives your body more time to develop that trained immunity and protect yourself if you do get the flu. So that is my myth buster for immunology, and now I'm going to pass it over to Matt.
Awesome, that was actually really cool. Yeah, I actually learned about the flu shots in school, and I found it very interesting, the misconceptions around it. So thank you so much for sharing. My myth versus truth, and I focus more on myth versus truth on my Instagram page. Like I do, like every 3 days, I have one that kind of blows my mind as well. But one thing, for at least for studying wise, is I talked about multiple choice before, but now let's talk about true and false. If it's true or false, you have to guess which is the one that has the highest chance. Well, based on another study recently, this actually is quite a recent study, the best option is actually true, mostly because as humans, when we actually write out the question, we often think in a true response. We don't often flip our mind and think in a false response. So the true actually has a 56% chance of actually being correct. So that's kind of a short kind of myth versus truth. The other thing that I hear a lot is that they're either left-brained or right-brained, which frankly isn't true at all. We actually use pretty much both sides of our brains equally, and this idea kind of came from how one side of our brain sometimes controls the other side of the brain. For example, when you're writing with your right hand, it is often more left brain dominance. But that being said, there isn't just a whole side of your brain that's more left side or more right side. So I think that's something that's a very common myth, but isn't very true. I even remember taking a test in grade 10 saying if I was left or right brained, and I thought it was true, but it's not. So something very interesting to share. Now on to Katarina sharing some language tips.
Thanks, Matt. So the myth I think, I want to share with you, and I think many have encountered in their life, is that people think they're not talented enough or they're too old to learn languages. And that's a total myth, and that's a total misconception. Like, I sometimes talk to people and I'm like, all right, wait, they tell me, I want to learn this language. And I tell them, why don't you learn this language? I'm not talented enough. I think that's not true, because it's actually shown that adults learn better than kids. And many people think that kids learn languages best, but that is just because they're in the environment of this language. So they actually pick it up so fast. But the thing is, it's actually a myth that just because you're older or just because you think you're not talented, you cannot pick up the language, because it's actually, and I think many people can agree with me, and I'm sure also you can agree with me, it's actually all about consistency. It's all about practice. Of course, nobody gets born and knows how to make math equations. It's not about talent all the time. Of course, you can be more motivated to learn it so you get better over long term, but it's actually how consistent you are in a language. And that's a great quote I read today. They say, like, you want to be fluent in a language, work for it. And I think many people can agree. Like, if you work for something hard, you will get fluent. It's not about you being too old or you not being talented. But Bexy, what do you have for us?
Hey, that was really good, Katarina, but it's annoying because I always say I'm inherently rubbish at languages. So you've kind of taken away my excuse there for trying, but yeah, so my Mythbuster, it's a common misconception that's actually permeated into kind of everyday language. And it's that weight and mass are the same thing, and they're not. So when we talk about, oh, how much does it weigh? How much do you weigh? We should actually be asking about mass. So mass is like the amount of physical matter that's in an object, and it's unchanging and it's measured in kilograms, whereas weight is a force and it can change depending on which planet you're on. So the equation for weight is mass times the gravitational constant. So like the gravitational constant here on Earth is 9.81 meters per second squared. So yeah, that would make it different to if I was on the moon. I would weigh a different amount because the gravitational constant on the moon is 1.6 meters per second squared. So if I weighed like 100 kilograms, just to make it easy maths, if I had the mass of 100 kilograms, I would weigh 981 newtons here on Earth, whereas on the moon, I would only weigh 162 newtons, but my mass would still be the same. I would still have a mass of 100 kilograms. So if you're wondering how scales then work, then they work by measuring the force that's being applied to them, but they'll be calibrated to know that the gravitational constant is 9.81, and it will take that into account. And so it will measure your force, but it would read back to you your mass in kilograms. So if you took some scales from here on Earth and took them to the moon, it would give you a completely wrong reading of your mass because it would be divided by the wrong gravitational constant. So yeah, mass is not the same as weight. And if you refer to your weight in terms of kilograms, then you are wrong. That's that. Over to Danny.
Thank you. I mean, so like just going on that, I remember in school when we were taught this, I'm like, yeah, that makes sense. But I don't think you're going to change the way people speak. I mean, you never know. Maybe everyone will change their mind. But so again, like I don't really have like a fact, so I'm going to go with a bit of theory. This is a little bit of something like personal to me, but also to some other people. Being busy is not the same as being productive. So when I was younger, I was always told, oh, you're really busy. You must be really good at doing whatever. No, no, I was busy doing stuff. But again, very similar to what I said at the start. Just because I'm busy doing things doesn't mean I'm actually doing anything that's useful, that's worth doing, that's intentional. So there's a couple of things that I've done through Notion. You could do with many other things to prioritize your time. One technique that I know Matt's done a couple of stuff on is called the Pomodoro Technique, which is essentially you do 25 minutes on, 5 minutes off, or you can change that time up depending on where your flow state is, how you're feeling. But essentially, if you do 8 hours of work one day, you might have done nothing towards your goal. If we go back to the essay example, I know when I was doing my essays for first and second year, I was a very busy person cleaning the house. It was not getting my essays done. So I wasn't being productive with my time. And something else that you could use is the Eisenhower Matrix, which is essentially two-step question. Is it important? Is it urgent? If it's not, if it is, and it just says, should you do something? Should you schedule something? Should you just delete it, just get rid of it? Or do you need to action it? And there's loads of other different ways and things that you can prioritize your time. But essentially, just because you're being busy doesn't mean you're being productive and getting where you want to go. So that's my little tip. Over to Chelsea.
Yeah, that makes a lot of sense. So my myth is a pretty common myth in biology, and I see it a lot as a biology teacher. It might seem pretty simple, but there's a big misconception, especially again with students, that evolution and natural selection are the same thing. So evolution, as some of you probably know, is the change in species over time, while natural selection is the process that drives evolution. So people get them, they use them interchangeably when really they are kind of different. So for an example, if modern humans suddenly went back to the Ice Age, we wouldn't suddenly mutate, right, and start sprouting thick coats of fur. Instead, the individuals that happen to be hairier due to their inherited genes would have more insulation and be more likely to survive the cold, reproduce, and pass on their hairy genes to their offspring. So that's the process of natural selection, which gradually drives evolution over time. So that's it for me.
Thank you, Chelsea, for that, because I get a lot of high school students when I teach them asking me about that difference, and it is something key that we need to get into, everyone's minds. And thank you to Matt for all his brain and mythbusters, because I get them asking me all the time, do we only use 10% of our brains? I'm like, no, your brain is going 24/7, it never stops working. So my mythbuster is based around my field, so Alzheimer's disease, and it's something that I get asked by a lot of people, and it is that dementia is not a disease. So what dementia is a set of symptoms, and this can manifest in many different ways, but the reason behind these symptoms is the death of brain cells called neurons. So what dementia is this group of symptoms which is caused by different diseases. And one of these diseases is Alzheimer's disease. So you can have Alzheimer's disease, meaning you have a dementia, but if you have dementia, you don't necessarily have Alzheimer's disease, because there are many different diseases which can cause dementia. So it's a question I always get asked, what is the difference between dementia and Alzheimer's disease, as one example? Well, dementia is this syndrome, a set of symptoms, and Alzheimer's disease is a disease which causes dementia. So that's just more terminology based, but I think it's so thread into the media about these people have dementia, and it's okay, yeah, they do have dementia, but we're not treating dementia, we're going to treat the diseases that cause dementia. So just separating them terms a little bit there for you. And that's it.
Thank you, Julia. I'm sorry to go straight back to you, but we've had a question, and I think it links in pretty much into what you just said, actually. So this has come from Maverick Nebula, and says, I've noticed in different older people, sadly, when they are in their final months, they will enter a stage of forgetting everything, losing the ability of making basic calculations, forgetting who they talk to, etc. Does the brain in their last months of life enter a stage of Alzheimer's, or is there another reason?
So with people as they age, they are more likely to get a dementia of some form. The biggest risk factor for developing a disease that causes dementia is age. And when you get to above 80 years old, it's 1 in 6 people on average will have dementia. So it's more so if people live to that late stage in life, they are more likely to have this brain tissue loss. And what you see with older people is that their brain is a bit smaller. It's like shrunk at post-mortem compared to a healthy young person. And that is because you do lose brain cells over time with any sort of aging anyway. But it's not necessarily Alzheimer's disease or like a dementia caused by another disease. But yeah, if you get older, the older you are, the more likely you are to end your life with a dementia. So that could be why you notice it in, you know, many different people with age.
Awesome, thank you very much. Right, there's another question for me. I didn't feel like I should be talking so much, so that's why I went straight back to you. So there's a question for me as well from Anwurul Alvi, who's asked me about some of my recent videos I did on the SIR model. So I guess I can sort of address it. So Anwurul, sorry, let me make sure I get the right name. Anwurul has asked me if it's possible to use the SIR disease model to make predictions about infection rates in the future. In short, yes, but I would also add a massive note of caution in that it is a model, and so any predictions about future events are going to be incredibly uncertain and rely on a lot of assumptions which might not necessarily be true. But in short, the SIR model separates the population into 3 categories. You have S, which are your susceptibles, which are people that can catch the disease. You have I, which are your infectives. They're the people that currently have the disease and are spreading it. And you have the R, which is the removed section of the population. So these are people who have caught the disease and have then either recovered or died. So they've been removed from the population altogether. And what you can do is you solve the set of equations and you get a graph which looks something like this. And it's probably going to look familiar to all of the coronavirus curves that people have been seeing over the last few months. So you have your S is going to, you start with everybody is susceptible, and then some people catch the disease, so that will decay over time. So at the beginning, everyone can catch the disease. After some amount of time, nobody is longer susceptible because either the disease is gone or they've all caught it. You have your infectives, which starts very small, and then you increase because the disease starts to spread. So you have your infectives, which will go up and then hopefully come back down. So this would be I. And then you have your recovered. So again, at the beginning, nobody has caught the disease and recovered yet. But over time, gradually, most people will catch and then recover from the disease. So this one is R. This one going up and down is I, and this other one is S. So this is time. And so what you could do with this model is you can then say, well, if we are currently here, based on the data I have, I know that most people are susceptible. I've had this amount of infections. You can sort of predict where you are. And then if you want to know what will happen in, say, 2 months, you just go along 2 months and draw your vertical line. Now, that would give you a very, very rough estimate. And again, this is a super basic model. The SIR model is like the absolute first rung of the ladder on disease modeling. So real models are way more complicated and give you way more information. But you could, in theory, use the SIR model to make a prediction about the future. You just look for where am I now based on my data and how far in the future do you want to make that prediction, find that time point, and then just read off the values you've got there from the model. Okay, so I hope that sort of answers your question and morale. Thank you. Right, I don't think there's anything else, so I guess it's on to round 4. Woo! So this is a personal fact, so I'll keep mine short and sweet because again, I feel like I'm definitely talking way more than everybody else here. The personal fact I want to share with you all, which some of you may know if you've seen some of my videos before, is when I was a PhD student, I was working on a particular project which was looking at climate models. And what we wanted to do as part of this project was we ran some computer simulations which came up with a prediction about certain properties of the ocean that we thought were having a major effect on the climate, but were not currently included in climate modeling. So all of these predictions we make about climate change, global warming, etc., these are based on models. And at the moment, we had this particular feature called sub-mesoscales, if you want the technical term, but we thought this was playing an important role, but we just didn't have the data to back it up. So in order to get the data, I was very fortunate and got to take part in our piece of field work. We went to the Southern Ocean, which is the ocean around Antarctica, and I was on board a ship for 6 weeks, which is a very long time to be living on a ship without making land. And I'd never been to sea before as well, so it was definitely an experience. Let's put it that way, but a little bit crazy. So I spent 6 weeks on a ship sailing around the Southern Ocean near Antarctica, collecting this data, and then we had data which we could then verify, and it supported our case that this particular feature of the ocean, these sub-mesoscales, were, we think, having an important effect on the climate that wasn't currently taken into account in climate models. So the hope is that next time we run a big, massive set of climate models, which is usually done every 4 or 5 years, hopefully our sub-mesoscales will be included because our data did suggest that they play an important role. So my personal fact is I spent 6 weeks at sea, and as much as I loved it, I probably wouldn't do it again. One of those, glad I did it, but you know, once is enough. Right, over to you, Gabby.
All right, so I have my dog here with me for my personal fact. And so I've always been an animal lover. Up until I discovered that research could be a career, I wanted to be a veterinarian. And so outside of lab, I volunteer at a local humane society. One of my biggest responsibilities is walking dogs. And I actually adopted a rescue dog. This is my rescue dog, Duke, that I adopted during my first year of grad school. And I'm actually going to be doing a podcast in a couple of weeks about why adopting my rescue dog during grad school was the best decision of my life. Oh, he doesn't want to hang out with me anymore. That's too bad. But because I have an additional degree in genetics, I got some genetic testing done on him to figure out his breeds. And he is 5/8 American Staffordshire Terrier, 1/8 Boxer, 1/8 Standard Bulldog, and 1/8 Labrador Retriever. So that is my fun fact about me, just being an animal lover. So over to you, Matt.
I'm also an animal lover. That was great. So my little personal fun fact is that when I was in high school and even in elementary, I used to work really, really hard, kind of what Danny was saying. And I was just working really hard, and I thought, you know, because I was working hard, sometimes I didn't get the grades that I would have wanted. And I didn't understand because I was working so hard, but it just didn't show through my results. And I think once I figured out the difference between being busy and being productive, it completely changed the way I've been able to actually work. Notion has been a large part of that. Danny, I'm sure you know a thing or two about that. But yeah, so I think once you learn how to be productive and how the difference between studying and being productive and studying efficiently, especially, there's often debate between using music or not listening to music when studying. And then there's different ideas. But I think once you find your own kind of workflow when you're studying, even learning anything, the possibilities really skyrocket. I found that once I learned how to do that properly, everything else was simple, and I had time for things that were more important to me, like family and friends, and it's been huge. On to you, Katarina.
Thank you, Matthew. It's really interesting what you say about busy is not equal to productive. I really need to get this into account. But the personal fact I want to share is, I shared already that I'm Italian, I'm from Italy, but my native tongue is German, and that's what I wanted to explain. So why is it that not people know about this? Why is it that in Italy there's some people talking German as a native tongue? And I show you why. All right, so this is Italy. I'm from this region. It's in the very north, near Austria, and we're like 500,000 worth of minority of German speaking in Italy. And that's the thing, like we're completely German speaking. Of course, there are people who are bilingual, but I didn't grow up with Italian. Just in school, I learned Italian. So with my friends, with my family, I just talked German. And that's why I'm not perfectly fluent in Italian, and I'm still Italian. So I'm Italian, but at the same time, not really. And the thing is, that's really interesting in our region, is that we talk German, but we don't talk standard German, we talk a dialect. So many German, like people from Germany and from Austria, come to our region because there's beautiful mountains, there's a lot of great nature, but they always have problems with the German we speak, because we speak a dialect. And I show you something. All right. So this is how you say Monday. I don't know if it's mirrored, but I hope you can see it. It's like Montag, Montag. But we say Montag. So Germans wouldn't really understand. So we say, it's a bit crazy. Then there's another word, just hello, hello, hello. We say hoi. And I mean, we are able to speak standard German. It's just a bit different. And so, yeah, Germans and Austrians wouldn't understand us when we talk. So that's my little personal fact. Let's go to you, Bexy.
Hoi, thanks for that, Katharina. That was really interesting. I was wondering how your native language was German, but you live in Italy, so yeah. So my fact is that I was born with a cleft palate. So it's basically a defect in pregnancy. My mouth didn't form properly, so I was born with a huge hole in the roof of my mouth, and it kind of stopped at the front of my mouth. Some people, you can get cleft lips and palates, and that can go onto your face as well, but I just had the cleft palate. So yeah, lots of operations and stuff growing up, and also lots of speech therapy. So like, my friends wouldn't believe this, but when I was younger, I used to have to be actively encouraged to talk. But because it was just really difficult to say certain words, and not everyone would understand me, and it's still sometimes I still struggle to say certain letters, and I'm quite nasally. But yeah, that's quite a big part of my life and childhood. And just another quick fun fact is I play a Dutch sport called korfball. So it's spelled like K-O-R-F ball. And I don't know if anyone's heard of it in the chat, just let me know, because I probably know you, because it's such a small sport. But it's kind of a mix between netball and basketball, and you have two halves of the court with two posts. So it's like, yeah, you catch the ball and stuff. And yeah, I play in the National League for my club here in Bristol, and I play for Scotland as well, because my mum's Scottish, so I can represent them. So yeah, any korfball questions, send them my way. On to you, Danny.
That's actually really interesting. Obviously, my undergraduate's in sports coaching, so korfball was one of the sports that we went over. Handball's actually like one of the sports I got involved in. So handball originates in Germany, France, that sort of European, and it's extremely small, very similar to korfball in the UK. And whenever I'm playing handball locally or nationally, like we are definitely a minority. So when we're playing on court, there's like German, Spanish, French, all of them swearing in their own language at the referee, and I don't understand any of it. And I'm just standing there like, I don't know. Whatever I say, everyone understands. So very, very quickly before like my personal fact is a question I get quite a lot actually. Whenever I'm on a Zoom call, a Skype call, business call, anything like that, people think this is a Zoom background. It's actually my wallpaper, so I just put my camera up there. So it's actually my wallpaper, just sort of like putting it out there, because a lot of people like ask me, oh, where did you get that? Where did you find that? Like, it's just my wall. So a fun fact, well, sort of a fun fact about me is I'm actually half deaf, so I can't hear anything this side at all. So that's why my mic is there, and like everything else comes out this side. So when we were doing like messing around with stuff, everyone could hear what was going on, like feedback, because I had my TV going on this side, so I could hear what was going on. And my sport is trampoline, or is trampoline. And because of my hearing, it messes up what's called the vestibular system, which is essentially like balance. And obviously on a trampoline, you need good balance. Needless to say, it took a lot of time to make sure I didn't fall off when doing somersaults. It took much longer to learn them. So doing doubles and triples afterwards, I got there. But yeah, so being half deaf obviously didn't help in sport, but also it's good and bad. So at school, I could lean on my arm and I couldn't hear a thing. Or if I sat on one side of the classroom and the teacher was the other side, I couldn't hear a thing. So most teachers didn't bother asking or anything like that. It didn't look at my file, maybe because they were lazy. Very similar in lecture when I was at uni. They'd be talking at me and people were next to me like nudging me and like, they're talking at you. I'm like, oh yeah, I'm listening. So yeah, my hearing is it's a blessing and a curse sometimes. Over to Chelsea.
Wow. Okay, so my fun fact is that while I also love science, I, in my spare time, am an actress. So that kind of what drew me to science communication and wanting to do some fun videos and kind of putting those two passions together. And in the last year, I was in a horror film, a very indie, very B horror film, which is really fun to, pretend to, I guess, kill people, but that's not really fun. But the whole process of being in a horror film is pretty fun, as you could probably imagine. And then my other fun fact is I am really into doing wine tastings. So if you can see this picture up here, and partly why I'm into wine and go to a lot of wineries is really, again, the science behind it and the ecology and how, it goes from root to wine. So I find the science behind winemaking super cool as well. So that's me. Not a real killer.
I want to come wine tasting with you, Chelsea. Any excuse to get a rosé, any excuse. So actually, my fact is like the same as yours, Chelsea, because I originally was very torn in life between becoming a scientist or becoming an actress. So I have this like passion of, I obviously love science, but I've been performing on the stage since I was like 3 years old. And throughout my university undergrad degree, I spent probably more time in rehearsals for musicals than I did in the library studying, which, I should have like a part-time degree in musical theatre. So yeah, I'm really, really passionate about performing, and I dancing, whatever, put me on a stage, I'm happy. And yeah, that's also what drew me to science communication. And I've been really fortunate over the past, 9 months or so, I filmed a document, which is sort of like hush hush in the net. I can't say much about it, but it should be out in the next month or so. And I flew over to America to film that and present it. So when that's out, I will let you know.
Sorry, I couldn't find the button to click on mute. Being super, I was too involved in hearing more about your awesome, everyone's awesome passions. Right, that brings us to the end of the fourth round then, doesn't it? Okay, right, I'll see. Did anyone spot any questions get thrown out for people? These ones could be more interesting, well, not more interesting, could be slightly different questions, seeing as we've all been talking about the kind of stuff that we do, not necessarily when doing science. Well, first of all, I want to know more about korfball, Bexy.
Yes. What do you want to know?
Well, is it the weird thing with the ball, the sponge ball that has holes in, or is like an odd shape?
No, so it's like it's a K5, so it's the same size as a football or a netball. It used to be a leather ball, and it's recently moved to some sort of foamy, spongy material. So it's much more lightweight. And the posts are like 3.5 meters high, so way taller than a basketball post, and no one can slam dunk. And yeah, you just have to shoot it into the hoop. It's mixed gender, so you have 4 females and 4 males in each team, and you're kind of like, there's 2 of each down each end, so you have 4 people on each team down each end. And so yeah, that was really good for me growing up, kind of getting to know different people and stuff. And I found it really fun at uni as well, because it's like great, integrated sport and everything. Yeah, definitely give it a YouTube, because a lot of people actually, when I say corfball, ask if it's either lacrosse, so is it the one with the sticks, or handball, like you, Danny? So yeah, it's not. It's got like this huge yellow post thing, and it's a bit like netball or basketball.
Okay, I think I was a million miles off then. Sorry. I think I was just picturing Quidditch. I don't know.
Yeah, some people do ask if it's Quidditch, and I'm like, no. Is it called Quidditch? No.
We have a Quidditch society in Oxford. I've never played, but they actually meet up every week and play Quidditch games, which is awesome. That even exists. Right, Chelsea, what's the film called? You're not getting away with telling us you're in a B-roll Hollywood horror film and then not telling us the name of the movie.
It is called Psychotherapy, and it is on Amazon.
There we go. All right.
A B horror film, so.
And Matt, there was a question for you about a book you recommend. So do you want to just talk a little bit about that? I know you put it in the chat, but
there's two different books that I think really helped me in terms of productivity. One of them was Flow, and Flow is essentially, well, I'm sure if you've worked before, you enter this kind of weird state where you're just only working and everything around you is just kind of like non-existent. And this idea is called Flow, and there's a whole book about it, how to enter this state of maximum productivity. That's one book I really recommend. There's another book called Essentialism, and it talks about what is essential in life. That's also a really good book. So those two books, Flow and Essentialism, is a great start for productivity.
Awesome. Thank you.
I was just going to echo that. Like they are good books. There's loads of books out there, but I'm just going to echo that point.
Yeah.
Double recommendation from both Matt and Danny. There we go. Okay. Right. Thank you very much, everybody. Right. I think we can dive into the fifth and final round. So we're going to say some facts about famous people in our field. So I decided to talk about Pythagoras. So because I felt that most people will have heard of Pythagoras. I think it's one of those things where even no matter how much maths you've done in life, you have this equation, a squared plus b squared equals c squared, drilled into your head so much as a doing maths at school that just, most people don't remember what it means, but they know a squared plus b squared is c squared. So it's sort of related to that. So Pythagoras is a very interesting chap. And I should say all of this, there is varying amounts of evidence to support what I'm going to talk about. I'm not claiming this is truth. There are certain documents that agree with what I'm going to say and some that disagree. But you can do your own research. But I'm going to focus on the fun, let's say the fun side of it. So there are various accounts that Pythagoras had very, very strong views. So he was credited with this theorem, which was probably also he stole from other people, but we won't go into that. But he had very, very strong views about the fact that everything in the universe, in the world, should be made from whole numbers. So based on this idea of triangles and a squared plus b squared is c squared, this sort of developed into a stronger idea that in fact, everything was made from whole numbers or ratios of whole numbers. So you're allowed fractions, but you're not allowed numbers that can't be written as fractions. So for example, the number pi would be a very big no-no to Pythagoras back in his day. And what happened was he developed a school, the Pythagorean school, and he was teaching this idea. Many other people as well were teaching this concept about everything can be written as ratios of whole numbers. And it kind of was described in various documents as a bit of a cult. So first of all, it's potentially quite hilarious that there was a maths-based cult in ancient Greece, but this is, some of the evidence suggests this was indeed true. And these people became fanatic about everything being whole numbers and ratios of whole numbers. And then this chap, Hippasus, comes along one day and he's studying the most basic right-angled triangle. So your side length A is length 1, B across the bottom is 1. And so your diagonal is 1 plus 1 is 2, square root of 2. So the length of the diagonal is going to be the square root of 2. And Hippasus showed that the square root of 2 could not be written as a fraction. So he showed the square root of 2 was an irrational number. It's like 1.41 something, 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 goes on forever. So you cannot write the square root of 2 as a fraction. And Hippasus did this very, very clever proof. It was a proof by contradiction. It was possibly one of my favorite pieces of maths ever, because it was done so long ago and was such an important result, showing us that some numbers exist that aren't fractions. But bless him, poor guy, he did this. But then, of course, this goes against everything that the Pythagorean cult believed, because he has just written down an irrefutable mathematical proof. So he's used their own tools, their own language against them, so they can't argue with it. And so what they did basically was to sort of trick Hippasus and say, well, you know, well done, mate. Let's have a big celebration. We're going to have a boat party. So they went out on a boat, big ship, went out to sea. They then tied him up, tied a load of rocks to him, and threw him overboard. So poor Hippasus, for doing this completely awesome piece of maths, and one of my favorite pieces of maths, showing the square root of 2 cannot be written as a fraction, was literally thrown overboard from a ship and drowned and murdered for doing maths. And that was all coming from the Pythagorean school. So I don't know if Pythagoras was involved. I think this was a little bit after his time, but an interesting story. And I also quite like it because it shows that, well, first of all, maths is pretty badass, right? Like, a dude got killed for doing an awesome piece of maths. Like that's just crazy. So that is my famous person fun fact. Over to you, Gabby.
That was a crazy story. Oh my gosh. And so my famous person that I'm going to be talking about is Jonas Salk. So some of you guys may have heard about him before. He is an American virologist, and he got his MD in New York, and he decided that instead of becoming a practicing physician, he wanted to do medical research. And so he kind of came onto the scene by developing the polio vaccine. And he developed it and announced it at the University of Michigan, which is where I am currently doing my PhD. And so he announced it at the University of Michigan Union. And so whenever I go by the Union, it has a little sign there saying that that is where Jonas Salk announced that the polio vaccine was completed and able to be widely distributed. So just a little fun fact, not only about my university, but about a famous immunologist. So go blue, and right on over to Matt now.
Awesome. That's actually very cool. That's in the same university. That's crazy. So I think I wanted to talk about someone that I feel a lot of people know about is Albert Einstein. Particularly, I wanted to talk about a little bit about what I want to be talking about in the video that I'm going to be releasing the next couple of days. But essentially, Einstein, just a little fun fact that Einstein actually slept 10 hours a day. So he slept a lot. But I think the important part about that is the importance of sleep. You connect different connections between your brain, and it's huge in actually remembering topics from the day before. And some interesting things is that I think it's very important to remember your dreams. I think it's something that Jim Quick talks about a lot, but it is so vital because the DNA structure, for example, that was from a dream. The periodic table came from a dream, right? And if you miss out, and if you don't remember those dreams that you have, you miss out on a lot of potential of discoveries that can be made in science, in math, and all the different fields that we're in. So Einstein, because he slept so much, it is said that he was able to create ideas and see things that people weren't able to see because he was able to create those connections longer. Now, I don't recommend sleeping 10 hours a day, but I do recommend getting that sleep priority is number one for sure. And on to Katarina.
Thanks, Matt. I was struggling with my sleep lately. I was just sleeping 5 hours, but I guess I shouldn't. All right, so a little fact I have from famous people, and it's not just from one, because I don't really know famous polyglots, people who speak many languages. Of course I know, but like there's not one that popped into my mind, so I want to speak of them all. I think a fun fact about all of the polyglots is that many of them didn't know they were good at language learning, and that's what the myth is about. Like, they didn't know that they were talented in the language, and that's the thing. Like, now most of the good polyglots now, most of the people who know many languages, I can name Benny, very good polyglots, they started their youth, they started their adult life with knowing one language, and that's English. Or I think many people in this world are the same. Like they thought they were not talented in learning languages, but then actually when they grow older, when they grow more passionate about languages, then they slowly start getting into languages. So that's, I think, a fun fact about many polyglots. They thought they were not talented, but they resulted that they totally are, just because they were dedicated. All right, Bexy, on to you.
Thank you. So I've just got a couple. My first one's about Albert Einstein as well, but Matt, I did really like yours because I love to sleep a lot as well, so that's good. But yeah, Albert Einstein, whilst he was married to his first wife, he started pursuing a relationship with his cousin, which is lovely. And I think when him and his first wife divorced, it took about 3 years before him and his cousin got married. And they were like blood relatives, so their mothers were sisters. So that's really fun. Another one is that Marie Curie is the only person to have won a Nobel Prize in 2 different sciences. She won one in physics for her work on radiation and one in chemistry for her work on radium and polonium, I think. So yeah, that's really cool. Woo, Marie Curie. And my third one is Stephen Hawking. He was given 2 years to live at the age of 21. So he was diagnosed with ALS at 21, and he was told he wouldn't live past 23, which is really sad. But he lived to a lovely age of 76, which is really nice and lovely. So yeah, on to you, Danny.
I feel like I'm really going to under-deliver after hearing all of those. I'm like, I should have thought of something better. So I assume many of you are familiar with Carol Dweck, growth and fixed mindset. If you're not, essentially, she suggests that you have 2 different types of individuals, and then their mindset, growth being you accept challenges and you push yourself to develop, fixed being you don't like challenge and you try to avoid it. And the fun fact is actually that she's not going against what she said, but she actually tries to turn it the other way around. So task orientation and ego orientation are linked with growth and fixed mindset, and she's talking about a false growth mindset. So essentially people are pretending that they have a growth mindset. And it was just interesting that some of her research, like previous research on growth and fixed mindset, she's now not going against, but she's almost doing a mirror. So a false growth mindset and a false fixed mindset. And to me, looking into psychology, obviously it's very theory based. It's just interesting to see how she is essentially mirroring her research, going sort of like, I was going to use reciprocal then, but Tom's here, so I'll probably say that's the wrong word to use for maths. But yeah, so sort of like doing the inverse of her research, which I thought was pretty interesting. Over to Chelsea.
All right, so I'm going to talk a little bit about Charles Darwin, of course, with biology. So as you guys probably know, he is known for the theory of evolution and theorized that all species came from a common ancestor that evolved over millions of years. And he called this process natural selection. And he published his ideas in On the Origin of Species, which actually took him 20 years to publish from when he made his observations. So a couple fun facts about Darwin that some people probably don't know is he was actually born on the same day as Abraham Lincoln. So in researching some fun facts about Darwin, I learned that obviously they were in 2 different parts of the world at the time. And he was also a medical school dropout. So I just find that interesting because you wouldn't think that unless you knew about it, but also it means like he wasn't doing what he wanted to do, and then he went on to discover evolution. So that's kind of an awesome thing to think about. Yeah, that's it. On to you, Julia.
That's so interesting. Like, yeah, definitely gotta follow your passions. Like if he can do it, so should we. So with the field of neuroscience, it's relatively new. There aren't like, your big figureheads from hundreds of years ago that you would necessarily say they're a neuroscientist. So I went with a man called John O'Keefe. I don't know if anyone's heard of him, but he got the Nobel Prize in 2013 for discovering that in our brains, there are certain cells which map out your environment, and these are called place cells. So if you put a mouse into a maze, you can actually track where it is in the maze depending on different cells in this small region of the brain. So these cells sort of light up. If you're in the top left corner, a cell will fire, and then if you're in the bottom right corner, a different cell will fire, and it maps out your whole environment. So he won the Nobel Prize for that, and he's actually a professor at my university. So that's why I went with him, because he lectured me the year he won the Nobel Prize, actually. And then I actually saw him in the pub like just before lockdown, and I was like, it's John O'Keefe, the Nobel Prize winner. So yeah, that's John, and he's like, yeah, really enhanced the field of neuroscience and learning more about what specific cells in the brain does. So yeah.
Awesome, thank you, Julia. So I know somebody, I don't know if this is going to count as neuroscience, and I'm going to apologize in advance because it probably isn't, seeing as it's not my field, but I happened to interview somebody in Oxford a few years ago who was studying optogenetics.
I know him. He's my friend's dad. Is it Giro?
Yes.
Yeah.
Right. Okay. I was going to ask. So for anyone, like, we're just having a private conversation here. Giro Miesenbuch, right? I don't know how to say it. Yeah. So awesome chap. And he's basically, and he showed me this experiment. It's crazy. He takes a fly, a little like normal standard house fly, and then alters like some setup in its brain, let's say, from a non-technical perspective. And then you can shine, I think it was, he shined a blue light, and the fly was flying around happily. Then the blue light turns on and the fly landed and instantly fell asleep. He was basically controlling the fly's, like, you know, its behavior in wanting to sleep by just activating the part of your brain that makes you go to sleep. It sort of implanted this trigger such that if the fly saw blue light, it would know immediately it needs to fall asleep, like bang, done, out. And I didn't believe this. And then he showed me the experiment, and it was the most ridiculous like sci-fi thing I think I've ever seen, because he was like actually controlling the brain of a fly.
With light. He's amazing. He's like, founded optogenetics, which is exactly what you said. We can sort of implant something into neurons, a channel, and when you shine a light on it, it either activates or inactivates that population of cells, and you can literally change an animal's behavior. But yeah, he's my friend's dad. That is quite a fun fact. So she went to UCL with me, did musicals together. So he's probably seen me dancing around on a stage. So that's, you know, a fun fact.
Awesome. Right. Thank you, everyone. We have now done all of it, haven't we? Wow. Awesome. Woo! Let's all have a celebration. Okay. So there were a few other questions. So I thought we should just, ideally, I think I've got a question for pretty much everybody, more or less. So hopefully we can each just have a go at answering one final question that's come in from the live chat, and then we'll call it a day. So who's going to kick us off? This depends on what order I wrote down these questions from the chat. I think, first of all, I had one for Gabby, actually. Well, I say I have one for Gabby. One that's come in for you, Gabby. So this is from Sam, who has asked, how does using viruses for targeted treatments work?
So I haven't really done this much before, but a lab that was a couple labs down from mine at Michigan State, where I did my undergrad, did this with bacteria. So I'm guessing it's probably about the same technique for bacteria or viruses. And so what he would do is he would take bacteria or certain molecules that bacteria were secreting and inject them into tumors. And so our immune cells would recognize the either the bacteria themselves or the different molecules that the bacteria would secrete as foreign, and it would activate the immune system. And because all of the source of it was buried inside the tumor, it would kind of chop away at the tumor and destroy the tumor in order to get to the bacteria or the molecule that they had implanted into the tumor. So I'm guessing it's probably the same thing with viruses, but probably just a little bit different. So I hope that helped and answered your question.
Awesome. Thank you, Gabby. Right. So as Gabby said, Sam, I hope that was answers your question. Thank you very much. Right, which one have I written down next? Let's go to Katerina. This is a question. This has come from me. So I want to know what's the easiest and hardest languages that you've had to learn? So you said you're on your 6th language now?
Yeah, the easiest and the hardest. Like this comes, every person's surely has a different opinion on that. But since my language, like my mother tongue is German, I think English was the easiest to learn for me because it's very similar to English, German and English. And the hardest for me, maybe Italian. Because I think Chinese, the grammar itself isn't that hard. I think Italian because it has a lot of vocab, it has a lot of grammatical rules. It's just not the same as German. And actually, I'm Italian. As I said, sometimes I speak a lot of Italian. In my sports, for example, I only speak Italian, but it needed a long time for me to even pick it up. Yeah, that's my answer.
Awesome, thank you. I remember attempting to learn Chinese myself a few years ago. Didn't get very far. But yeah, I did French. I did French for 5 years at school, then forgot it all, as most people do if you don't practice. So yeah, I wouldn't necessarily say, because apparently I'm meant to be able to learn languages because it sort of links to maths and patterns and things. Again, I don't know. I'm sure somebody more qualified than me can tell me if that is nonsense or truth. But anyhow, thank you. Right, Bexy. A question from Linda, who has a suspiciously the same surname as you, who has asked, how does fusion compare to other renewables?
Yeah, thank you for that one, Mother. That curveball. You're lucky that I'm quick at maths. So I think a wind turbine can produce about 3 megawatts. And the reactor, the fusion reactor that Colin was trying to produce, should be producing 1 gigawatt. So this means that one reactor would kind of produce the same amount of energy as 300 turbines. Okay, and then based on that maths, if one turbine can power 1,500 homes in a year, then a nuclear fusion reactor should be able to power 500,000 homes in a year. So that's kind of how it compares. It's about 300 times better. Yay, I hope I got that right. Tom, you can tell me later.
That was some quick maths. I'm impressed. Thank you. Right, Danny, one for you, again from me. I'm just full of questions today. I'm intrigued. Where did your idea, like the first idea for Notion, come from? What was that like, that moment of inspiration where the light bulb just dinged and you were like, I'm doing this. This is going to be something I want to do?
Well, to start off with, it's not like my app. I didn't develop it or anything like that. It's just something I've used. So essentially, when I was, what was it? I think like beginning of 3rd year. So I'd gone through I'm not going to take any, because obviously my hearing, I didn't take notes because as soon as I write down notes, I just couldn't hear what was going on. So I went through a stage of not taking any notes and then realized I was forgetting everything. So I was like, okay, I'll take loads of notes. And then I just had loads of paper everywhere. And I was like, now it's just a mess. So I needed some way to store notes. And I went through, some of you may know Evernote. I've used Evernote, but I didn't like the fact that I would take notes, put it in Evernote, and then I'd be like, where's it gone? Because it was the same problem as having all the Post-it notes in the paper. I've used Todoist, I've used Trello, I've used Asana, and then I could list a load of other apps, but I won't bother. And essentially, I came across Notion about beginning of 3rd year. So that's over 2 years ago now. And what I like about it and what like made me stick to it is you can build what you want. So you could just write down stuff and use it as a doc. You could just use it as like a writing doc for notes, or you could then design it. So at the moment, a lot of people are using it as a website. So instead of using Squarespace or Wix, you could use Notion, completely free. Or you could use it as a task manager for businesses. I'm currently helping out a couple of businesses for KPIs and OKR tracking. They've recently updated their inline maths. I'm sure you'll love that. But essentially, you can create equations in Notion, like all the actual drawings. I think it's like KTeX and LaTeX language. You may know what that means, but essentially, you can put all like the symbols and stuff in there. And And then with databases in Notion, you can surface things that you want, surface things you don't want, and essentially you can create whatever you want, as long as you understand how the blocks work, which is what my channel is about, helping people like build the space that they want to use. So the reason Notion is where I went rather than anything else. I think ClickUp and Coda are two others that are quite common, is they have restrictions. So you have to see it in this view, or you have to put these things here. Notion, you just make it the way that you want. If you like bright colors, put loads of bright colors on it. If you want it boring, like white and black, go white and black. If you want it really complicated and have formulas and code, like, I mean, I've got like 45 line long formulas to like one box. So if you want to do formulas and code, you can. If you have no intention of doing that, you can just stick with just writing notes on a tick box. So the versatility, I was just like, I love this. Like, I could do what I want. So yeah.
Awesome, thank you. LaTeX, I use LaTeX to write my PhD thesis. So I do know what you're on about there.
Yeah.
Yeah, it's all about writing those equations. Absolutely. All right, there was a question for me, and then I've got questions for everybody else, but I figured I'll go next because I get to choose, because apparently I'm in charge. So Sam has asked me, why is 0 factorial equal to 1? So I should first of all explain what a factorial is. So a factorial is defined as follows. It's a mathematical thing. We write it with an exclamation mark. So if I want n factorial, it's n exclamation mark, and that just means n times n minus 1 times n minus 2 all the way down to 2 and then 1 at the end. And you just multiply all of those numbers together. So if you want the factorial of a number, it's just the number itself times all of the numbers smaller than it and stopping at 1. Now, where this comes from is to think about, or the mathematical definition is, it's the ways of arranging n objects in a line. So if you think about it, let's say we consider 3 factorial. I'm thinking about n is equal to 3. I've got 3 objects, A, B, and C. And then you can ask, how many different ways can I arrange these 3 objects, A, B, and C? So for the first object, I could go, well, let's say I could go ABC. I could also go ACB. I could go, this is hard to do, BAC, BCA, CAB, or CBA. And that is all of the possible ways of arranging 3 objects. And 3 factorial is equal to 3 times 2 times 1, which is 6, which is exactly the same number that I got from doing my exhaustive list. So if n factorial is the number of ways of arranging n objects, then if we're interested in 0 factorial, how many ways can you arrange 0 objects? The only answer is 1. There's only one way to do it, and that's like to have nothing. So that's kind of why it's equal to 1, is a way to think about it. So the 0 factorial, like, this is like the odd case. Everything else hopefully makes sense, because if you've got 2 objects, if you've got just A and B, you can have AB or BA. So there's 2 ways, and 2 factorial is equal to 2. So it makes sense for all of them. 0 factorial is the kind of odd case, but we say that it's equal to 1 because there's only one way to have 0 objects, and that's just to have 0 objects. There's nothing else you can do. So that's why 0 factorial is 1, Sam. Okay, right. I got a question for Chelsea. Don't know what happened to my voice there. Chelsea, question for you. So you do biology. I mean, I may be way off with this, but a lot of my friends who did some form of biology got to dissect some pretty cool things. So I'm intrigued as to what is the most interesting or wacky, or just any experiences you've had with dissections.
Yeah, I got to dissect a lot in college, and I was a teaching assistant, so I got to do it every semester for like 4 semesters. And nothing was really too wacky. I dissected like pigs and worms and things like that. But we also dissected dogfish, sharks. And my one wacky experience was that I dissected one that had baby sharks in it. And there was about 4 little baby sharks in the dogfish. So that was really interesting and kind of sad. But yeah, that's my only like kind of real weird experience with dissecting.
I like how you described dissecting a pig as not a weird experience. I think
Oh,
I'd be
is that not
terrified if it was literally like, here's a pig. Like,
yeah, fetal pigs.
I think I did a
like
frog at school, in high school. I think I did a frog, or maybe we did a rat, something like that. It was sort of as wacky as we got, but not.
Yeah, pig is, I think, pretty common, and maybe in the US. I don't know. But Bexy asked how I can dissect a worm. It is so small. They're like, it's really another weird experience, actually. You just kind of cut it down the middle and then splay it open. Yeah, it's kind of gross too.
Awesome, thank you. Right, we've got a question for Matt, which is, it's come from Danny, in fact. Why did you start using Notion over other apps? Matt, are you there? Have we lost Matt?
Like Matt's disappeared.
Oh no, we've lost Matt. Oh no. All right, well, maybe we'll come back to your question then, Danny. Matt seems to have been lost to bad internet connections, which we don't know anything about at all when trying to do this live stream. Right, so in that case, I think just a question for Julia then, to bring us to the end. So Julia, you mentioned you're currently finishing your PhD. So I know I'm not supposed to ask this, because I remember absolutely hating being asked this question myself when I was writing up my PhD. But when are you hoping to finish it, and what are you going to do next? Like, what's the big dream goal?
Yeah, so I was meant to be submitting in September, but now with lockdown and everything, I haven't been able to go to the lab, and I did have like a few bits that I needed to finish off to like complete the thesis. So now I'm waiting for the lab to reopen and for me to be able to get in to do the stuff that I need to do before I can fully finish. So at the minute, I've like made all my figures that I can. I'm currently writing up my intro, and then I will put together the discussion as much as possible, but it's a bit hard when you haven't got those final, last little pieces of the puzzle. So yeah, hopefully I'm aiming for it to be done by the end of the year, in the sense of all the lab work, all the thesis, hopefully Viva by the end of the year. And then after that, I think at the minute, like the plan for me is to move into science communication full time and take that passion for talking about the brain and all the knowledge that I've learned over the past 8 years and get that out to the general public. So yeah, I'm probably going to transition from academia into communication. So yeah, that's the plan.
Awesome. You should do both. I can highly recommend both. It's a lot of work, obviously, but that's kind of I'm super fortunate that I'm able to have my like teaching aspect and a little bit of research, and then do like communication as well. But fantastic. Okay, so I think Matt has now returned. So Matt, we have a question for you from Danny.
Yeah.
So Danny wants to know, why did you start using Notion over other apps?
Yeah, okay, great question. So I used to be the kind of guy that I always have like lots of ideas going through my head, and I used to always write my notes in like the Apple Notes. And I found that it was so kind of disorganized, and there wasn't any like relation between notes. And once I found Notion, I found it through a YouTube channel called Keep Productive. And then coincidentally, I also found Danny around the same day. So technically it was both of you guys that kind of inspired me to start Notion. But anyways, so I started using Notion, and I found it was amazing how you're able to categorize stuff. Like it wasn't folders. Like I think that's the thing that's a huge misconception. It wasn't folders. It was just like how like pages are connected to other pages, and then those pages have notes, and it's hard to explain if actually showing you actually Notion, but it's absolutely genius how it works, and it's completely changed my workflow.
Awesome, thank you. Okay, right, I'm going back to gallery view. I think we can all be sent to screen again. Right, so that's it, right? We've done all 5 rounds. We've answered lots of questions. I noticed there are some other questions, but we definitely want to keep this. It's already gone on for a long time. So I think hopefully we're all happy. You're all happy. Thank you everyone for tuning in. Thank you to all of our amazing other Educators Assemble team for taking part and sharing with us their awesome knowledge and passion for their subjects. And I guess final shout out to say, check out everyone's channels. If there's someone in particular that you really have thought you're interested in what they talk about, or even them as a person, I'm sure we'd all be happy to hear from any of you if you have any other questions. If you have questions we haven't answered, if you write them in the comments, then we can all answer them or send them individually, etc. So again, thank you for tuning in.